Algebra 2 Honors, Lesson 8.3, Log Functions and Inverses. The objectives of this lesson, the most important things, we have to be able to learn how to convert between log and exponent form and how to evaluate logarithms. Okay. First thing, let's talk about exponent form. And then log form. So exponent form here, let's say we all know 2 to the third power is equal to 8. If we were to convert this to log form, right, so the base of the exponent, here's the base, here's the exponent, here's the result. So basically it would be log, right, and then the base of the log is the same as the base of the exponent, so log base 2. Alright, now the result, alright, of 8 is equal to, and then the exponent, which is 3. Okay, so these two, alright, this is in this is considered in exponent form. This is considered in log form. Okay, so just the main thing is you just have to understand and remember where the values go. So the base, the exponent, the result. So the base, alright, so it kind of goes counterclockwise. The base, the exponent, the result. Alright, and the way this is read is log base 2 of 8 is equal to 3. Okay, log base 2 of 8 is equal to 3. Let's try another one real quick. Let's say we have 3 to the 4th power. We know that equals 81. So in log form, it would be log base 3 of 81 is equal to 4. Okay? And you have to be able to convert backwards too. If they give it to you in log form, let's say for example, log base 5, 125 is equal to 3. Alright, log base 5 of 125 is equal to 3. In exponent form, this is going to be 5 to the 3rd power is equal to 125. Okay? So log form, exponent form. So to sum it up, basically, exponent form, let's say we have b to the x power is equal to y. The way the book represents it with just variables. So we have some base, right, to some sort of exponent is equal to y. In log form, it would be log base b, right, of y is equal to x. Okay, so the most important thing is just to be able to convert back and forth between exponent and log form. Okay, let's talk about a few things regarding logarithms. So basically, a logarithm, right? We have a log. Okay, so then we're gonna have the base, right? Then we have the result here. I'll just call it the result. Right, is equal to the exponent. A few things to keep in mind. In log form, the result here, alright, cannot be negative. Okay. If the result happens to be negative, then the problem is considered undefined. Okay, it cannot be negative. The base, alright, the base is a positive. Alright. The base is pretty much always going to be positive. Alright, any positive value. Alright, positive value. Except 1. Okay, so the base is always, it'll be some positive value, but except positive 1. Okay, except for positive 1. So keep in mind that regarding logarithms. Another thing, if you ever get something like this, let's say for example log, and let's say they don't write anything. All right, if you ever get a log or something in log form, and they don't show the base, or they don't give you a number here, you can automatically assume that there's an imaginary 10 here, okay, base 10. All right, so anytime they don't give you the base, all right, it's okay to assume that, oh, that means that they're telling you it's base 10. Okay, so anytime they don't give you the base, you can assume that there's an imaginary 10 there. Okay, it's up to you to write the 10 if you want, but in the book, if they just write log and they don't give you a number, you can assume that there's an imaginary 10 there. Okay. All right, and a few other things let's take a look at. Let's say we have log base 3, and then we have 1 here. Okay, so if you think about this, now sometimes there's a few logarithm problems where if you just take a look at it, it'll be pretty obvious what the answer would be. So here, 3, let's think about it. Basically, when you're trying to figure out what this is right here, it's 3 to some power, right, is going to equal 1. Well, 3 to what power equals 1? 0. Okay, so let's try another one. Log base, say 13. Alright, now same thing. 13 to what power is going to equal 1? It's going to be 0. Alright, so the main idea that you need to kind of know here is, look, when the result here is positive 1 right here, alright, so that means that the exponent is going to be 0, because anything to the 0 power, alright, anything to the 0 power equals 1. Alright, like 13 to the 0 power here, that equals positive 1. Alright. The next thing, let's say we have log. Oops, let me rewrite that. Four. Now, whenever your base and your result is the same, right? Or if you just think about it, 4 to what power equals 4? It's going to be 1. Okay, so when the base and the result are the same, that means that this value here is going to be, alright, this equals 1. Okay, same way if you have like log base, 8 of 8, well, 8 to what power equals 8? Well, positive 1. Okay, so you have to recognize these, alright, these kind of simple logarithms when you guys see them. Okay, where the ones where the answer is 0 or 1. Okay, and it doesn't always have to be, they could give you, it doesn't always have to be normal numbers. You might have other stuff, alright, that looks kind of confusing, but the whole idea is the same. Like for here, if the base and the results are the same, if they're exactly the same, right, that means the exponent has to be 1. Okay, and if the result is 1, alright, regardless of the base, that means that the exponent has to be 0. Okay. And then let's talk about evaluating. Okay, let's talk about evaluating. So let's say we have, well, let's talk about, let's say if we have, let's say like log 4 base 4 of 16. If you have something like this, it's really simple, right? Because you could probably figure this out in your head thinking, oh, 4 to what power gives you 16? Well, 4 to the second power, alright, gives you 16. Alright, so when the numbers are easy like this, you can mentally work out the logarithm in your head. But it's not always going to be this easy, and the numbers aren't always going to be nice. So let's say we have something like this. Log base 16, let's say 32. Okay, so log base 16 of 32. So we're gonna have to think, well, this right here, all right, what is this going to equal? All right, well, it's kind of hard to figure out, like 16 to what power gives you 32. Okay, like we don't really know, all right, what that is, because 16 to the first power is 16, and 16 to the second power already is going to be 256. All right, so in order to figure this out, you're gonna make this logarithm equal x, and we're gonna find out what this is going to equal, what the exponent should be. Now, in chapter 8, there's two forms. There's log form and exponent form. I would say about 85% of the time, it'll be necessary for you to convert between one form to the other. Okay, so in order to do that, right here, if it's in log form, we're going to have to change it to exponent form, which would be 16 to the x power is equal to 32. Once you do this, the next thing you want to do is you want to get the same base. Okay, you have to get these numbers here to be the same. Right? So you have to think, and we kind of did this in chapter 7. So what value can we use to get the same base here? Well, I know 16 is 2 to the 4th, right? Then you still have the x out here. And I know 32 is 2 to the 5th. Okay, then follow the exponent rules. So 2 to the 4x is going to equal 2 to the 5th. Now, you have an equation here. Basically an equation says the left side of the equal sign has to be exactly the same as the right side, right? Now, since we have the same base already, 2, right? So if the bases are equal, that means the exponents have to be equal to each other, right? So we're trying to figure out, well, what value of x will make this right here 5, okay? So that allows us to set the exponents equal to each other now. So once you've gotten the same base, you can set the exponents equal to each other. So that's real simple. 4x equals 5, so x is going to equal 5 over 4. So if you plug in 5 over 4 here, right, then these are going to be equal to each other because the 4's will cancel and you'll be left with 2 to the 5th. Okay? So that's how you find out what a logarithm equals, all right, if the numbers aren't so nice. All right, let's try another one real quick. Evaluate. So let's say we have, let's do a fraction one, log 27, 1 over 81. So same idea, all right, obviously, really, difficult numbers to work with here. You probably can't do it mentally in your head. So what you're going to do here, you make it equal x. Let's find out what this is. Convert to exponent form. 27 to the x is equal to 1 over 81. 27 to the x is going to equal, this is going to be 81 to the negative 1, right? So 27, that's 3 to the 3rd, because we need to get the same base now. 81, right? Now, since this was a fraction, you want to write it so it's not a fraction, so that's why we have this 81 to the negative 1 here, right? Because 81 now we know is 3 to the 4th. Follow exponent rules. 3 to the 3x is equal to 3 to the negative 4. We've got the same base. It's okay to set the exponents equal to each other. 3x is equal to negative 4. So x is going to equal negative 4/3. Okay? Negative 4/3. So this value here is negative 4/3. Okay? So the one additional step here is this. What's different in this problem is this right here. If this happens to be a fraction, rewrite it so that it's not a fraction. All right. So 81 to the negative 1 is the same value, just written so that it's not a fraction. Okay. And the last thing, let's say we have log base. Okay. Now looking back to what I talked about earlier, remember we said the result could never be negative. So if the result here is negative, right, the answer to this is going to be undefined. Okay. Now, first of all, a few things to keep in mind here. I didn't write a base here. So if I didn't write a base, remember, that means that there's an imaginary 10 there. Okay. Now the two answers that I'll get from students are obviously 2. Alright, now let's check why 2 obviously is going to be incorrect, because 10 to the 2nd power, right? If you're saying 2 is the correct answer, does 10 to the 2nd power, is that going to equal negative 100? No, right? 10 to the 2nd power is 100. Alright, so obviously this is incorrect. Alright, so once students realize that, they think, oh, this has to be negative, so they'll say, oh, the answer must be negative 2. Well, let's think about if we do 10 to the negative 2 power, is that going to give you negative 100, right? Well, 10 to the negative 2 is really 1 over 10 squared, which is 1 over 100. That doesn't give you negative 100 either. So this one would also be incorrect. Okay? That's why the result cannot be negative, because there's no exponent that's going to be able to give you a negative value right here. Okay, that's why it's considered undefined when the result right here is negative. Okay.